We have seen that the internal energy of a system can be increased by heat transfer, work transfer or mass transfer. Now suppose if you are working with a system which is with a fixed amount of gas, like a closed system, that is where the transfer of energy is allowed but transfer of mass or matter is not allowed, then in that case for suppose if we write for a closed system, the increase in internal energy can be done only in these two ways, that is by either by supplying heat or doing some work on the gas. Okay, so we have already seen that the increase in internal energy for a system is equal to the heat absorbed by the gas plus the work done on the gas. So now if we bring this term work done on the gas, okay, on the side of the increase in internal energy, then we will have heat absorbed by the gas equal to increase in internal energy minus work done on the gas. Okay, now we can use the concept that suppose left and right are two opposite terms, and then suppose east to west are opposite terms, then we can say that left is we can think that left is like negative right, or suppose west is negative east. So if we have two opposite terms, then we can think one of as the negative or minus of the other term. Okay, so the concept of so for a thermodynamic system there can be two types of work, like work can be either done on the gas or work can be done by the gas. Now these two concepts are also opposite of each other. Okay, so we can think one term as the negative of the other term. So if we have work done by the gas, that is the gas is doing the work by itself, then it will be negative of the other term, that is work done on the gas, that is work is being done on the gas by some external agent. In this case there is no external agent in work. Okay, so what we can do, we can replace this minus work done on the gas by plus work done by the gas. Okay, so then this relation, okay, becomes that heat absorbed by the gas, so heat absorbed by the gas is equal to the increase in internal energy plus work done by the gas. Okay, so this gives the idea for the or the foundation for the first law of thermodynamics. Okay, so the concept that how the internal energy of a system can be increased, that by either by absorption of heat or by doing some work on the gas, it gives the foundation for the first law of thermodynamics. Okay, so you see the first law of thermodynamics states that if heat is supplied to a system, you see in this case heat is absorbed by the gas, then a part of it is used to increase the internal energy, that is you see the increase in internal energy. A part of the heat absorbed by the gas is used to increase in internal energy, and the rest of the absorbed heat is used in doing some external work by the system, so work done by the gas. Okay, so if Q amount of heat is absorbed by this system, then a part of it is used to increase in internal energy. So UF is the, we know that U denotes the internal energy, UF for means the final internal energy, UY is the initial internal energy. So UF minus UY will give us the increase in internal energy, and if heat is absorbed, then UF must be greater than UY. Okay, plus the rest of is used in doing some external work by the system, so we have plus W. Okay, so plus W means we have the external, so the work is done by the system. Okay, now there is another form of statement for the first law of thermodynamics which goes like this. Okay, so for a closed thermodynamic system, that is, there is only exchange of matter is allowed, exchange of energy is allowed, but no exchange of matter is allowed. In such case, if there is an increase in internal energy, then that increase in internal energy will be equal to the difference between the heat transferred into the system. Okay, that is, heat is transferred, heat is absorbed by the system, heat is supplied to the system, and the work done by the system. Okay, so it is the difference between heat transferred into the system and the work done by the system. So for a thermodynamic system, increase in internal energy, suppose this is plus delta U, which is the increase in internal energy, then this plus delta U is equal to the difference between, so difference between two terms. Which two terms? Heat transferred into the system, so plus Q minus the work done by the system, and we know the work done by the system is minus plus W. Okay, so plus delta U is equals to plus Q minus within bracket plus W. So it can be written like this: delta U equals to Q minus W. Okay, so the first law of thermodynamics is basically the conservation of energy principle. So it says that if some heat energy is supplied to the system, then it will not be destroyed. It will be converted partly into the internal energy and partly as some work done by the system. Okay. Next is the differential form of the first law of thermodynamics. So when an infinite small amount of heat dq is added to the system, so that this heat does two works. Okay. One, it increases the internal energy by a very small amount du, and in addition it also performs an external work which is also very small, dw. Then we can say that according to the first law of thermodynamics, dq equals to du plus dw. So this is the differential form of the first law of thermodynamics. Now this du is called exact differential in thermodynamics. Why? Because U, as we know, it is a state function. Okay, that is, it depends only on its value depends only on that particular state at that moment. It does not depend which process or which path is taken to establish that state. Whereas this dq and dw are called inexact differential in thermodynamics. Why? Because we know this heat and the work done are path functions. That is, they will depend on the path which is taken between two states. Okay, between the initial state and the final state.